Today we're going to do 6-5 solving square roots and other radical equations. So I will be able to solve the square root and other radical equations. The essential understanding is solving a square root equation may require that you square each side of the equation. What's going on? This can introduce an extraneous solution. So we'll keep that in mind for later on. To solve a radical equation, we are going to isolate the radical on one side of the equation and then raise each side to the power suggested by the index. So what does that mean? Get the radical by itself, do the inverse operation. So if we are square rooting, then we will square both sides of our equation and solve for x. I'm going to get the radical by itself by subtracting 3. Whoa, sorry. From both sides. And I get the square root of 2x minus 3 is equal to 5. Since my radical is now by itself, I'm going to square both sides. And 2x minus 3 is equal to 25. I'm going to solve for x by adding 3. 2x is equal to 28. I then divide by 2 and get x is equal to 19. Sorry, I'm being silly. 14. Once I have my solution, I need to check by plugging it in. So in my check, I am going to do 3 plus the square root of 2 times 14 minus 3 is equal to 8. 2 times 14 is 28 minus 3. 28 minus 3, 3 plus the square root of 25. So 3 plus 5 is equal to 8. Yes. To solve equations of the form x to the power of m divided by n equals k, we are going to raise each side of the equation to the power n over m, which is the reciprocal of m over n. If either m or n is even, then we're going to have to use the absolute value of x. But we have 3 times x plus 1 to the 2/3 power is equal to 12. We first need to get whatever's to raise to the 2/3 power alone, so we're going to divide by 3. I have x plus 1 to the 2/3 power is equal to 4. I'm going to raise this now to the 3/2 power, so that when I multiply my powers, they will simplify to 1. I will be left with x plus 1 is equal to 4 to the 3/2 power. 4 to the 3/2 power is the square root of 4 cubed. So x plus 1 is equal to the square root of 4 is 2, cubed is 8. Subtract 1 from both sides, and x is equal to 7. We're going to do this one as well. 3/5 root of x plus 1 cubed plus 1 is equal to 25. Subtract 1. 3 times the 5th root of x plus 1 cubed is equal to 24. Divide by 3. I'm going to write the 5th root of x plus 1 cubed as a rational exponent. So I have x plus 1 power over index is equal to 8. And I'm going to raise both sides to the 5/3 power, leaving me with x plus 1 is equal to the cube root of 8 to the 5th power, which is 2 to the 5th power, 2 to the 5th power is 32, is equal to x plus 1. Subtract 1 from both sides, and x is equal to 31. Checking for extraneous solutions. We're going to solve like we've been solving, and then we are going to plug in our solution. So I need to isolate my radical. X plus square root of x plus 7 minus 5. Mr. Smartboard is frozen. Hold on 1 second, please. Equals x. I'm going to add 5 to both sides. So I have the square root of x plus 7 is equal to x plus 5. I'm squaring both sides. Please notice that I am squaring x plus 5 means I need to FOIL. X plus 7 is equal to x plus 5 times x plus 5. So I get x squared plus 5x plus 5x plus 25. X plus 7 is equal to x squared plus 10x plus 25. Since I have a quadratic, I'm setting everything equal to 0. 0 is equal to x squared plus 9x. 25 minus 7 is plus 18. Triangle, what multiplies to 18 and adds to 9? 6 and 3. Therefore, I have x plus 6 times x plus 3 is equal to 0. So x is equal to negative 6 and x is equal to negative 3. In order to check for extraneous solutions, I need to plug into my original equation. I have x plus 7, square root of x plus 7 minus 5 equals x. So I'm going to plug in negative 6. Square root of negative 6 plus 7 minus 5 equals negative 6. Square root of 7 is 1 minus 5 equals negative 6. Negative 4 does not equal negative 6. Now we do negative 3. Square root of negative 3 plus 7 minus 5 is equal to negative 3. Square root of 4 minus 5 is equal to negative 3. Negative 3 is equal to negative 3, so yes, x equals negative 3 is our solution. X equals negative 6 is extraneous. If we have an equation with two radicals, we want to isolate the more complicated radical and then use that index, raise each sides of the equation to that index. So I'm going to isolate 2x plus 1, and I'm going to add square root of x to both sides. So it's 1 plus the square root of x. I'm going to square both sides. I'm left with 2x plus 1 is equal to, now remember this is times 1 plus the square root of x. So 1 times 1 is 1, plus the square root of x, plus the square root of x, plus x. So we have 2x plus 1 equals 1 plus 2 root x plus x. I'm going to subtract x and 1 from both sides. I get x is equal to 2 root x. Since I have my radical by itself now, I'm going to square both sides. I get x squared is equal to 4x. Subtract 4x. X squared minus 4x is equal to 0. Factor out an x. X minus 4 equals 0. Set each factor equal to 0. So x equals 0, x minus 4 equals 0. Add 4 to both sides. x is equal to 4. I need to check both solutions. So the square root of 2 times 0 plus 1 minus the square root of 0 equals 1. So this is 0, square root of 1 is 1, minus 0 equals 1, yes. Now we have to check 4. Square root of 8 plus 1 minus the square root of 4 equals 1. So 9, square root of 9 is 3, minus 2 equals 1. Yes, and we have 2 solutions down here. That's it.